Hello and welcome to yet another episode of This Is My Architecture. Today we are shooting at Amchi, Mumbai. I am Rohini Gaukar and I am joined by Dr. Ram Ramdas, founder and chief evangelist of WonderLend Hub. Thank you for joining us, Ram.
Thank you, Rohini, for having me over.
Great. So tell us more about what WonderLend Hub does.
Yeah, WonderLend Hubs is really passionate, born out of the passion for solving the problem of friction in the lending ecosystem. The friction of data, the friction of process, the friction of decisions for a market that we believe is more than 500 million Indians. And to address this market of more than 100 million households and tens of millions of small businesses is a problem or a challenge of huge scale, huge complexity, and the huge heterogeneity of the data that needs to be processed to be able to address this market.
Right. Okay. And so when you already have this product built, right? So can you give us more insights into these challenges that you have faced? I mean, I understand the scale perspective that you're aiming for in the future, but what are the challenges that you're currently facing with your product?
Great question, Rohini. The first version of the product is already deployed for one of our clients in a on-prem, kind of a mode. It's processing about 100,000 two-wheeler loans,
okay,
average 15, 20 seconds at the point of sale.
Okay.
So some of the strategic objectives of the client were achieved, but when we really look at this market, we felt that the whole digital lending hub needed a reimagination of the architecture.
Okay.
The way the backend works, the way the middleware works, and the way the front end works. And that's what we went about when we looked at reimagining this architecture. At the back end, we really had a problem of durability, high availability, and of course, the total cost of ownership. And hence, we actually made a significant decision to move from the SQL Server backend of our earlier version to our Aurora Postgres backend.
Okay.
Right? So that's one very key strategic decision that we made from a backend perspective.
Okay, so what I understand is you already have an on-prem version, and when you were thinking of the future of getting the market, you also thought that you need to reimagine the whole architecture for going onto the cloud. You just didn't do lift and shift, and you also told us about your choice for using Aurora Postgres SQL. So can you give us more onto why this choice and how was the experience with it?
Yeah, absolutely. As I said, one of the critical challenges was high availability.
Right.
Obviously, at an affordable cost, right? So we got that, out of the box. We have, read replica that we can, scale up, right? Mm-hmm. Scalability, because a lot of our deployments would start at typically a pilot scale, maybe couple of thousand loans per month, and very quickly could ramp up to tens and hundreds of thousands of loans per month. So we needed scalability, mm-hmm, and durability, and of course the cost. As I said, that total cost of ownership for just this component alone, in migrating from the earlier SQL Server based, I think we've got a 5x kind of difference already. Right?
Great. So you had a SQL Server box already running, and you used SCT and DMS to convert that into Aurora, and you had like 5 times.
Yeah. So
cheaper?
we used the tools that SCT provided.
Okay.
It was very useful for us. So we have 2 large schemas that runs at the core of the WonderLend Digital Lending Hub platform. Mm-hmm. The schemas consist of in excess of about 500, 600 tables.
Okay.
I think about, if I'm not mistaken, about 90 odd stored procedures.
Wow. Okay.
We were able to get about 55 to 60% automated migration on the stored procedures, and practically on the data migration, on
right,
the schema table migration, practically 100%.
Wow,
yeah.
and that's a great insight for viewers that you had these kind of improvements. Great. And what about the rest of the architecture? So can you just walk us through how the whole thing works?
Yeah, absolutely. Very happy to do that. So typically, the request would be invoked by the end user, a borrower, in a direct mode, assisted mode, or even through a third-party aggregation kind of mode. Mm-hmm. Comes through the Route 53, hits the elastic load balancer, mm-hmm, hits our the WonderLend API gateway, as we call this. This then interacts with a number of third-party services. Some of these are more what I would call as conventional services. Some of them are more alternate data services. Some of them are driven by user consent. Some of them are real-time system-to-system kind of integrations. And all of these are written back in real time to the core, and this is where our credit policy services, our scorecard services, our final loan decision services, and these are all highly user configured at runtime. So they vary a lot based on the products, the client segments, the kind of sources and the channels from which these loans come from.
Okay.
And then all of this goes back to the user.
Okay.
Target 15 to 30 seconds, as I said,
Yeah.
with maybe a 95% STP ratio, right?
Okay.
So that's really what this whole architecture is about.
So your original version, you broke it down into different microservices and you're running them in an auto-scaling group.
Yeah,
in the
so
backend as
so
well.
what we have done is through this re-architecting, we've essentially got a very, very robust service-oriented platform.
Right.
And then we are now able to add a lot of new services. And one of them is, for example, this what we call as the socio-economic
Okay.
profiler service.
Okay.
And this we are running today on a graph database called Neo4j on AWS,
Okay.
of course. And we are able to add these kind of newer microservices that add tremendous value to the end loan decision, because now the quality of decision is highly improved by using a combination of data that was already available and newer types of data that we can make easily available through WonderLend and via our partners.
Great, awesome. And this is a really great insight into this. So what next? What next for the architecture itself?
Yeah, there are a couple of things which are, I think, immediately there on our short-term roadmap. With all of this now data that we are able to process, we are looking to help our clients with better and improved analytical and decision-making models. So we will look at initiating some machine learning based services
Okay.
using the SageMaker.
Okay.
Some of the enhancements that we plan to do right now, there are about 45 alternate data variables through the Neo4j
itself.
database.
Okay.
In the next version, we are probably looking to double the number of variables that will be part of that alternate data service.
Okay.
So the complexity and the scale will grow, and we are probably looking to see if we can do a kind of a proof of concept with the AWS Neptune and see
Okay.
if that's a good option for us in the future.
Awesome. All the best for these POCs as well. And thank you for sharing the great architecture.
Thanks, Rohini. It was an absolute pleasure talking to you about this.
Thank you. And thank you for joining us for today's episode.